I need a confirmation on that too.
Yes, we can see.
That's awesome. So if we see the presentation, we can logically assume that we have a JavaScript functions lecture, and the lecture itself is split up by two parts, and this is logically the first one. So this lecture includes this lecture, which is practical examples, overall knowledge, and use cases of function. And we have another lecture, which is the day after tomorrow, which basically includes more in-depth technical questions about JavaScript functions. And for that, we will need some kind of visualization and presentation. But since today we are talking about just of use cases and like practical examples, we are just forgetting that this lecture exists and we are going straight to the Visual Studio Code. Is the font size good enough to see?
Yeah, it's good. We can
Yes,
see.
yes.
We can clearly see.
So this file is basically an overall understanding of syntax of functions, and let's write it one more time. So regular functions are declared by the keyword which is function and following by the name of the function itself. Let's name it sum of 2. And to understand what functions does, firstly I want to say for what functions are actually created. So the purpose of functions are to encapsulate long code inside of one single statement to not to repeat yourself and to call our functions from all around our code. So basically we can declare our function once and run it every time or wherever we want. So another understanding of function is that the function is an instance which takes data inside of it and returns some kind of a response. So function does something depending on the arguments which are passed. When we are getting back to the syntax of the function, we have a name followed by the parentheses, and parentheses are exactly the point where we are including some data inside of the function. So for example, if we have A and B, it means that the arguments are passed and the data will be available from inside of the function. And after we having just the curly brackets, which are indicating that the block where we run our command started. And let's just console.log summing of two arguments. So functions by itself are objects. So there are programming language where any calling of the function, any mentioning of the function actually executes it. But in JavaScript, when we are calling the function, we have to add parentheses to it. So this is just the body of the function. If I console.log just this without any parentheses, that will mean that I console.log. So I just console.log this statement, nothing more. But if we actually want our sum to console.log a plus b, we have to add parentheses to it and provide the arguments which are mentioned here. So we want two arguments, so we could sum it. So we are doing something like 3 and 5. And if we execute the code, let me comment that out. Today we are working in Node.js environment. That doesn't mean that it won't work in browser environment. It's just more comfortable. There is not much difference between them in scope of this lecture, but if there will be any difference, I will point that out and we will move to the browser console. So in this case, if we added two arguments, if we node function usage.js, we will get out 8, which is actually the console log of this function. So the purpose of this file is just to memorize the syntax and to see how we can actually see the code in like our flow, how we can identify functions. Another way of using functions is using them as a method. I will write that from scratch. So as you know, objects in JavaScript are pretty complex structures. So they can have A, which will be 5, for example, and they have B, which is, I don't know, 12. And then we can declare a property. So for example, sum, which will take a function as an argument. So it's pretty normal to put a function inside of inside of a property of an object. So basically, if we declare a function, note that we don't need name inside of this statement because name is already declared here, and later we will call that function by this name, by the sum. Um, I'm guessing someone has its microphone on, so yeah, that's better. So here we are console.logging. When we are using our objects, we have to say explicitly that it is this A plus this B. What is this will be discussed later. It's not the purpose of this lecture, but it is essential to understand how functions operate. So on this lecture, we will have quick overview of what this does. And on the next one, we will go in depth of what function, what this and context is and how to manipulate it, what is the problem with it. And when our function is an property, let me comment everything out. Oh, in this case, we are just referencing that some, like, if we wanted to take A, we would say object.A, and we would get 5. If we wanted B, we would say object.B. In case we want function to execute, we would say just object.sum, which is the name of it. And then again, we are adding parentheses to it. So this will actually give us this A plus this B. Again, this is not in the scope, so it's okay if you don't understand what it does. And again, this function, so the function which is passed as a value of a property of an object is called method. Another example of function usage is function constructor, which is pretty much out of scope as well, because function constructors is just the regular functions from the prospect of JavaScript, from the prospect of implementation, but they are called with keyword new, and it's basically something which was doing object-oriented code before classes existed. So JavaScript is a really old language, and um, most features of it appeared not from the beginning, because at the beginning JavaScript was just a language to move a picture around the screen in the browser. So the only thing I want to mention here is that notice that function constructors have naming conventions of start with uppercase word. So in opposite, if we want to just use regular functions, which we will gonna talk about today, all of the functions are lowercase. So the first letter is always lowercase because it's like JavaScript doesn't care about it, but we um, have like strong convention to differentiate function constructors from regular functions with just the first letter. And another way to declare a function is actually never used. Um, if I would ever ask someone on the interview about this syntax, and he wouldn't answer, I wouldn't be mad, because probably you will never use this. And the only use case for this I can think about is that sometimes when we are running, for example, React code or some kind of a long code, we have plugins to minimize our code so they can load more fastly, and bundlers sometimes generate this code. So basically, it's new function, which is the exact syntax we should use it, and we are passing arguments A, B, C, D, and the last argument is actually the body of the function. So it's the same as we have console.log here, but again, it's not mandatory to mention, and it's just for you to know that this exists, and probably it's very, very bad practice to use that anywhere in your code. So we already saw how to declare functions with function keyword, but it's not the only method. Function declaration and function expression is the terms that you will probably need everywhere. I mean, literally on every interview you will be asked about difference between them, and function declaration is something which we already talked about. So it's the function keyword, it's the name, it's the parentheses, and it's the block, which returns us something. So what's actually the difference? Let me comment everything out. So here we declare the function and then we called it. So it will normally compile, will give us something if we actually console.log the result of it. And it's just a function which takes an argument of a multiplier and just multiplies it by 3. So multiplier is 5, and here we will get 15 because 5 times 3 is 15. And the interesting thing about it that usually in any programming language, compiler goes line by line. So it's the first line first, then the second, then the third, and then it just proceeds down to the last line. But in this case, we can move this statement up. So we are basically using our function just before it was assigned. And in this case, JavaScript will give us exact right answer. Why? Because function declaration. So again, function declaration is a way of calling function with function keyword at the first time. So in first place, we have functions. So functions declared this way are actually hoisted. What is hoisting? So hoisting is a method which JavaScript interpreter has to compile functions before anything else. So when we are running this code, JavaScript compiler takes this function and moves it up to the flow. So um, that's because we can normally use our functions before they were assigned. So we can have our functions somewhere down here and it will still work because they are hoisted and they are declared with the function declaration syntax. But we have another syntax is here. It's a bit hard to tell which one is more useful because it depends on a lot of things. So basically, when we want to create a function, first approach we should consider is just a function. So this method, and then if it doesn't fit, we are choosing another one. And the another one is function expression. So before declaring any function, we are creating a constant. And after that, we are naming it somehow. So it was multiplied by 3. So we will leave that multiply by 3. And that constant takes function as its value. Again, here, like when we are just doing this function, it's mandatory to have a name on it. But with function expression, the name is already defined here, so it's not mandatory. We can just write function. And again, the syntax is pretty much the same, but the thing you should remember is that if our function keyword is at the right side of the statement, so if anything goes first, that means that it's function expression. And if I want to return something, let's say that this function takes an argument of multiplier, and we are returning 3 by multiplier. And if we call it down here, so it's absolutely the same. We are multiply by 3. We are passing an argument of 5, and we are expecting it to work if we wrap that in the console.log. We are really getting 15, but if we move this statement up somewhere here, it won't actually work. So it will give us a reference error. Cannot use multiply by 3 before initialization because JavaScript interpreter can't really see that the function is here. Because as you may know, you already had a lecture about constants. Constants are created at the moment when compilers comes to it. So compiler doesn't know that the function is here. And that's why we cannot actually, so it can be hoisted, it can be moved up, because for that, JavaScript would need to move all the statement up, and it's not possible because it's declared with the const or with let. It doesn't really makes a difference. that's the main difference between function expression and function declaration, that the function expression are hoisted and function declaration is hoisted and function expressions are not. Also, I mentioned that in this use case, we may or may not provide a name. So we can pass a name here like we are doing with this, like some other name, but we don't have to. The only use case of this name is that, I don't know, you probably all take a test on like before you got here on Code Wars, and you probably know what recursion is. So basically, a recursion is a function which calls itself from inside our function. So from function, like this is the block of the function, and here I'm just calling it. It's like, don't pay attention to the logic here. It's just a classical example. And here I'm calling the function itself, and I'm calling it from here. So if you want to call a function, of course, we can do that with the get Fibonacci too. I mean, no one is stopping us, but it's good convention if you are using recursion, if you are using a function from inside your code, to use the second name. But the thing that I want to mention is that when calling our function, we can only call it by the first name, so by the get Fibonacci only, since the second one is just inside of that constant, so it's inside of this and can only be used from inside of the function. So if we get Fibonacci just like this, even Visual Studio Code won't give us any suggestion about what should be passed here and what should be not. And we will get an error because Fibonacci is never declared anywhere, just get Fibonacci is. So that's all the difference between declaration and expression. And the second topic I want us to talk about is arguments. So we don't need everything here for now. Let's write function accepting arguments. And some of you may already had experience with other programming languages, and in some of them, if we call arguments, for example, A, B, C, and we are just console.logging, everything works fine. And if we call that function, which with less arguments when we provide it, there will be an error. So I have 3 here, and I pass just 2. In JavaScript, it doesn't work like this. So we have so A is 1, B is 2, and the C became undefined. If we console.log C here, we will actually get undefined. We are getting undefined because C wasn't ever declared, but it doesn't mean that it's throwing any error. More than that, if we provided more arguments, 3, I don't know, 5, 12, and we only have 3 arguments here, it won't be an error also, because these 3 will be just regular. A will equal to 1, B 2, C 3, and all of the other arguments will be ignored. There is a way to get them, but we will get back to it later. For now, I want to say that functions treat arguments differently. So you know that in JavaScript we have different types, and all of the types except objects are really primitives. So primitives and objects are treated differently. So here I declared 2 variables. Let's redeclare it with const. It doesn't really make difference, but just know that when you don't need to reassign the variable, you should always use const, especially on a bigger project. So I declared 2 arguments, and here I have a function which basically is named change primitive arguments. And yes, for writing functions on this lecture, I will use a function declaration approach without any const at the beginning. It's just for the simplicity purpose, and everything will be written in the most usual and kinda first approach which we want to use. And this name, it just takes two arguments, the first and the second. And firstly, we are console.logging first and second. Then we are reassigning it. So we're saying that the first, which was given here, is 10 and the second is 24. At the moment where, firstly, initially, the first argument is 5, which we want to be a 10, and the second one is 12, and we want to make it 24. And when we are console.logging them again, so if we call our function, change primitive arguments, and if we pass like first argument as the first argument, and the second argument. So basically I am passing 5, these 5 and 12 here, and I'm expecting them to change. It actually be all right. So node, I don't have anything written here. So node passing arguments. So first console log showed us that the first is 5 because I passed it as a 5, and the second one is 12. I passed it as a 12. Then the reassignment happened, and the first became 10 and the second became 21. If we console that log out, we see that it really became 10 and 24. But if we go here and we console that log, the arguments we initially created, so first argument, second argument, we will notice that nothing actually changed. So yes, we reassigned it here. Yes, the console.log firstly showed us that the first became 10 and the second became 24. But outside of that, our variables stayed the same they were before reassignment. So we assume from that observation that the function takes arguments by copy. So this is not the same place in memory where this is. So basically it's just a copy. 5 got here and then 12 got here. We reassigned it here, but it doesn't really make a difference because in outer scope, outside of the function, first argument and the second argument points to the same place in memory where they pointed before. But things get a bit more complicated if we start doing that with objects or any simple structures like arrays. And like, as you may know, everything is object in JavaScript. Objects, arrays, even functions are objects. So here I just declared an object which has two fields. First one is size, which is 5, and the color is gray. Just a simple object, and I'm doing pretty much the same with it. So I declared a function which takes an object, and we are console.logging that object, and then we are trying to change the size. So I'm saying that object.size equals to 15. In that case, if we console.log object, I will see that at first it was size 5, color gray, and after I changed it, it became size 15, color gray. But if we console.log after the function was already executed, we will find out that in outer scope, so this object also changed its value. So this line changed the value of past object. Why? Because objects are always passed as a reference. So basically, this object is just a link to a place in memory. So in our computer memory, there is a place where size is 5 and color is gray. And it's just a link. And when we pass the link, we say that go to that link and say that size is 15. And then the compiler does that. It comes out that the object really changed its value because this object, and this object, and these objects are the same links. So be careful while working with objects because it can lead to misunderstandings, and globally in a lot of JavaScript modules, it's bad practice to when functions are affecting something outside of them. So it's bad then you're calling your function, and instead of just returning you the right value, it just changed something in the outer scope in unchangeable way. So you can just track down what was changed, and that leads to a lot of errors. So it really is like big difference between passing just primitives and objects to our function. Um, another um, another thing that I already mentioned is that our functions take in the arguments which we already talked about here, and they are returning something. But before that, I want to show you something on practice. So sometimes we don't know how many arguments are passed. So for example, I have a function which wants to sum all of the arguments. So what am I expecting here? What I'm passing as many arguments as I like. So just it can be 5, it can be 6, it can be 7, and I'm expecting it to return. So when I will call this function, sum all the arguments. So I will pass 1, 2, 6, 7, or I might pass 1 and 2. So there must be a way to determine what was actually passed as an argument, right? So that method exists, and it's called arguments. Um, you all know that the functions are just an object, so we don't have such type as function is, and that means that function will have its properties. So arguments is really a property of our function, and it holds information about the arguments which were passed. So if I have first argument as hello, and the second argument traditionally a world, if I say arguments 0, I should get the first argument. So I'm getting hello because in arguments pseudo array, the first index is taken by hello. If we write 1 here, which will be the second value in our arguments chain, it will be world. So by the arguments, we can really determine what was passed here. Another thing which arguments has, it's arguments callee. So arguments callee is actually never used, and it's just reference to the function body. So for example, if I remove this line and I call this command, it will just say that function was called and the function's name is sum of all arguments. So basically arguments.callee is a property which points that this function was called, and sometimes it might be useful to, for example, if you are doing some object-oriented way and you want to determine which function run your code, then you can just call argument.callee. And another thing which arguments has is argument.length. And that basically gives us the length, so how many arguments we provided. So we can have something else and 1 and 1 and 12, and in that case it will say that it has length of 4, I suppose, or 5. 1, 2, 3, 4, 5. Yeah, 5 arguments. So that's all the properties we can like get with arguments. But arguments, even if sometimes we can use it, it is not good to use it. It's a bit of bad practice, and it's somewhere like in the old days, because now we have a more modern way to count our arguments passed in the function, and it's spread operator. So basically, if I want to um, determine what is the arguments passed in my function, I can write this statement here. And then I'm just console.logging args. Notice that we are getting an array of all the arguments which were passed. Also, I want you to notice that arguments is just a name of the variable. I mean, it's not important to call it args. It's just a good practice to always call spread operator with to call it args. but it's not necessary. I can call it something else and it will work. So another difference, another thing I want to mention is that if I pass here another arguments like A, B, and something else, it will be different. So I will show you why. A became the hello and B became the world. But something in this array, we got everything which doesn't include in A and B. So if A is hello, B is world, something else will be everything except that. So that's why it's called rest operator. And it's just indicated by 3 dots. And also the thing you should notice is that the rest operator is always at the end of the arguments array. So it's firstly argument we want to declare explicitly. It's A, B, or maybe C. And only then we can put our rest operator. Another thing about rest operator is that, let me show you. Arguments is not an array. So if we want to call something like reduce or map or something, you may already like learn array methods, and it has a lot of methods in it, like, I don't know, map, slice, splice. It won't work because it's just indexed object. So basically arguments is an object which has which has 0 of first value, then it has index of 1, which is second argument, and so on. But spread operator is actually an array. And that's really big difference, and you should really notice that because on the interviews it's pretty much often asked question. And rest operator, like console.log something else, but we should really rename that to args. In this case, it will be an actual array. And if we put dot here, you will see that Visual Studio Code suggests every variation with array methods. So if my first task was to sum of all of the arguments, I can just say reduce because args is an array and arguments are not. And I can just call a reduce function here, and I can pass a value here and like call it as the regular array. Or if you don't know the methods of an array yet, you can just do a simple loop for let I equals to 0, I is equal to args length, I plus plus plus, and you can say that sum everything will have some kind of a variable here. Let sum equals to 0, and here we are just like passing sum plus equals to args indexed I. But it's like, well, the main logic here is not to sum everything, but to remember that there is a rest operator. That's how we can get all the arguments from it, and that's that the arguments is an array and the arguments is not. And that's basically it for the arguments, for passing arguments. That's everything I wanted to notice. And as I said, functions is something which takes argument, which we covered, and it's returning something. So let's look at the return explicitly. And before this moment, what we were writing was a function which was taking some arguments, and it was console.logging something. But let's imagine that we have to store this sum somewhere. So I created a variable here, and that variable will equal to result of this callee. So I expect this function to return, give me the value of some of these 3 elements, and then I'm just console.logging result. And if we do that, we will have 6 at first because console.log returned that value, so it just logged in the console that value, but the value of the result will be undefined because we don't have a return from the function. So return in functions is a point from where the value will be returned. So what the function, what we expect from the function. So console.log doesn't return anything. And the return statement I wanted to talk about is return. It's the keyword with which we can actually get something from the execution of the function. Want to notice here that if we write undefined, like return undefined, it will have absolutely the same result, console.log first, and then we get undefined. If we say that we are just returning something, it's absolutely the same. We are getting undefined as well. And if we are don't writing any return like at all, it will give us undefined still. So if we don't provide our return, it will be the same as if return like didn't exist or its value was undefined. But we can create an example where the function actually returns something, and that is return, and then we are just passing our value. So it was console.log before, and then I'm just saying that return a plus b plus c. So absolutely the same logic, except that console.log can be removed because I don't need it, and I just need that value, so 1 plus 2 plus 3, which will be returned in the execution of this function to be stored in the variable called result. So basically, if I run this, I'm getting 6 because that is the result. If I just move back our console.log, we will get 6 and 6 because firstly, this console.log logs its sum, and then the function returns the value. We are reading it from this result. So that's how we basically return from the function. And next thing I want to show you is that we can conditionally return from a function. So we have conditional return, which takes an argument of a, and then we are comparing that a equals to 0 and return just 0. And then notice that I have console.log compiler went here. So what I want to say with that is that if we run this function, this line won't be executed. So by the logic, it should log compiler went here. But since I passed 0, if became true, and I entered this section, what I want you to realize from that is that after the return, function stops execution. So code won't go any further because we already returned from it. So a function understands that that's the result that you wanted to get. And this part will be just ignored. But if I would pass 1, it would go here and it would say that a is not equal to 0. It would give false. It would skip this line. It wouldn't go here like if works. It would go here, and then if a equals to 1, it's just returning from the function. So remember that the function doesn't operate after it is returned. It's returned something. And basically that's it. We can return anything from the return. Also want to mention that if you have some long code, it's absolutely, how to say, needed in React, for example. You can wrap your code in parentheses and say that I don't know, some big condition like a multiplied by 2 and 3. So basically, if you don't have space or you want to make it multiple lined, you can basically wrap it in the parentheses. But it's better approach to just say a, and the a will be returned. As simple as that. So when we dealt with the return from the function, let's which one will be more appropriate? Okay, I said that we we'll discuss this a bit in the next lecture in depth, but for arrow functions and for other topics we will start with in the next lecture, I want us to have a brief understanding of what this is, and this can be understood as the object on which the operation was run. So let's start from this example. So this is a pointer, a link to the object which was used in the context. So basically, in the Node.js, it will be just global object. There is a global object and its window in Windows browsers. It's in the browser basically. And what it will show is that this is equal to a global object. Global object, for example, mm, first thing I want to notice here is that if we have useStrict, I will provide a link. You may read about that later. In this case, it will give me undefined if I use strict here. But in generally, if you don't use something like this here, this will just refer to the global object. What is global object? How we should use it? It's in the scope of the next lecture, so I won't talk about that a lot. But something I want to show is that this function. So let's create an object, or maybe this example would work. So we have a function which is say my name and which console.log this.name. Right now we don't have this and we don't have name. So it's just a function which does nothing. If I call it, it will just give me undefined. But then I created an object. So I already said that the object can peacefully say an argument, so it can take a value. And in this case, let me spread that out to be more understandable. I used short-handed property here. I just didn't write with with column, but I could do something like say my name. It's just the key, and it's just the value. But it's common practice if you name key and value, if the name of the variable and the name of the key is the same, you can pass just it as one. And basically what we are saying here that we have a function which lies inside of the object and which has name. And then I declared another object which has absolutely the same function here, but the name is Sarah. So one function calls it's identical functions coming from one variable, but the name is different. So if I call object 1, say my name, and if I call object 2, say my name, the results will be different. Node this JS. So the first call gave me Max and the second call gave me Sarah. So it gave me the result depending on which name was in that object. Let's think why. So here I say that this name should be console.logged, and I say that this is object before dot. So when I said object 1 say my name before the dot, so object 1 got before the dot. So I run say my name on object 1, and that's why this took object 1. Because this always refers to the object before the dot, it's like simple to say that object 2, this would become object 2 here, and if we follow that chain, object 2 has name of Sarah, and like if we call this function right now, it will give us the object 2 dot name, which will be Sarah. So basically this is the context of execution. So it refers to where the function was called. And just one thing to remember is that this is determined when the function is executed. So basically, everything else is determined when it was declared, but this in function context is determined in the moment we execute it. So when we run our function with our parentheses, then this takes its value. So before that, this is just undefined. This is not found, it's nothing. But then we provide that object one has that function inside of it. It explicitly calls that this becomes max, and max gets console.logged. Another thing is that our context is not a constant, so we can easily change that. And we have example for that. I'm not sure what I wrote here. So we have an object, and the object has its name and its corner, and it has the say name, which is a function which takes an argument, but let's remove that for the simplicity. It's just a function which returns this name. It's a regular method, as I already told you. And at the end, we want to console.log this.name. So we assume that if we are calling object say name, it will work correctly, right? Because before the dot is object, it search for object.name, because when we pass object here, it comes here, and the object obviously has its name here, which is Connor, and it will be right. So if we console.log here, it will be Connor. But what if I want to use this function outside of the scope? So I don't want it to be related to this object. I want it to do something else. So for example, I am declaring a constant, which will be say name. Oh, let's like leave it like this name, or say name global, and it is equal to object that say name. So I copied this function inside of this object, and I'm trying to execute say name global. In this case, I won't get anything, just undefined. Why? Because here I have nothing before my statement, so nothing goes, object isn't found, so nothing goes here. So the global object goes here, and the global object doesn't have any name, because name is declared inside of our object. And it will just break, and that's the moment I want you not to mess up, because it's really simple error, and we will go over that kind of errors in the next lecture. But for now, just remember that this is the object before the dot, and if function is called outside the context of an object, outside of the context of an object, this won't work there. But there is a way to, for example, I have another object is equal to an object. It's just a regular thing, like we are writing it always. And it's Sarah. It doesn't have any function, and I want this function to run on this object. So basically, I want to change the context of this by my hand without putting the function here, because in that case, I would have to duplicate my code, which is always bad, and say name would be written here, and it would be a lot of duplication. In this case, we have three methods of changing context. It's call, by, and it's bind. And that is three methods which are really useful, which you will see a lot in your practice, and which you will be asked a lot on your interviews, and it's good to have an understanding of how they work. So basically, I want to call a function. So I want to call a function, but I want this to become another object. So I'm borrowing function of one object to another. And here I'm just saying that object dot say name. So I'm just referring to this object, calling it. And here inside of arguments of our call function, first one is this. So remember, the this is pointed as the object before that, and I'm saying that this is another object. What am I doing here? I'm saying that take another object as your this, and then this function is executed. It changes this value, so this becomes another object. And of course, then the function is readed. Another object is this object, and the name goes from here. So basically, if I call this function, it will give me Sarah, because this became another object here. I want you to know also that if we have any arguments here, for example, 1, 2, 3, that arguments can be passed here as 1 or A, B, C. I must A, B, C. Here I'm passing 1, 2, 3. So it's basically just passing in arguments, and like we are calling say name function with this context, with this, and with these arguments basically. Also, we have apply, which is absolutely the same. So it just doesn't make any difference. The only difference is that if we would use apply, we would use another object as regular, but the another, like if we want to call it with arguments, we would pass an array here with 1, 2, 3. That's all the difference. I will probably provide a link about these three methods. But the only real difference is that here the values are passed, and here an array is passed with all of the arguments. Another thing which is really useful is bind method. So bind is something really interesting because it is used a lot, especially in React on event listeners and on big libraries. Here we were calling a function just once. But what if I want to change its context for good? So for example, I have an object here. I don't need this. And I'm just constantly logging A, which is hello, and B, which is world. And another object is just goodbye space. I mean, I didn't knew how to call the values, so it's just like this. And we have a concat method. And if we call it, we will logically get hello world because object, so it's the method, it's the object before dot, and it goes here, and object with method really has A of hello and B of world. But what if I want to have another function? So for example, if I don't want to call it from the object all of the times, I can tie them up. So I don't have to call it like before the dot, so I wouldn't have to pass anything here. In this case, I would use bind. So what it does is independent concat. So concat is just a name of the function, and I want it to run just like this, independent cont, like this, without any specification on which object it will be run. So I'm writing it like we tried with apply and with call, but in this case we are passing object with method concat, and then instead of call or apply, which will immediately call something, I'm passing just bind. Bind just like two other function takes this here. So I'm just saying that I want this function to be always run on another object. So basically I'm saying that you should bind together this object and this function. And I'm getting independent function. If I run it, I will get pretty much expected result, which is goodbye space. And it's really nothing more to understand that. There is in-depth comparison of these three methods, and I strongly recommend you to read them. So it's call, it's apply, if we want to immediately call that function once, and it's bind, if we want to create independent object and use it with the binding of any object and any function in the future. So again, about context and about closure of the function, we will explicitly talk in the next lecture, but today it's pretty much enough to understand, and we are moving to the which one to choose, let it be arrow function. So this approach is something which is really popular. It's another way of writing functions. It's short, it's comfortable, it's good to understand. And at first, I just gave you example of regular function, like we were writing it till this moment. And this method is function expression. So function, we told that const um, multiply. We know that if our function is at the right side, it's function expression. So you should know that arrow functions are not hoisted. So we cannot call them before we assign them. And then instead of writing function, name of the function, and parentheses and brackets, we are just writing our parentheses. Then we are writing our arrow. That's why it's called arrow function. And after that error, we don't need f here. We are just writing something to return. So it's just a multiplied by 3. Here, it's just the place to pass an argument. So it's the same bracket such this is. So here we are passing a. And here, notice that we don't need to write return. We are just passing the value here, which should be returned. So basically, I took this from here, passed here, gave it an arrow function, and then I took this part and moved it here. And after that, if I console.log multiply by 3, we've passed 5 values. These two functions will be identical. So node arrow functions JS, and it gave me an error, which is awesome. Console.log. So yes, I'm getting absolutely the same result. And also, here we have pretty short return, so we don't have really to do anything. But if you want to provide some kind of a hard logic, we can simply pass curly brackets here and treat it absolutely the same as we treat regular. So we can like declare a variable here, which will be 5, and which then we will say that const b equals 5 plus 3, 5 plus 3, and then we are returning something. So from this moment, we are treating it just as we treat regular functions. No difference, absolutely. Also, if we are not passing any arguments, we can write it without parentheses. So, or if we are writing just one argument, in case if we are writing one argument, we don't need any parentheses, but it's really strong convention, and also every single linter on the world will advise you that even if you have one argument, just wrap that in your parentheses. I mean, nothing will be hurt, and then pass as many arguments as you want. I don't know how to name it, but in this parenthesis, we are passing everything that we would pass here if we would write it as a regular function. If we do not have any arguments, we can just simply leave it blank, but parentheses should exist. So you can just do it like this. Parentheses should exist, and it's pretty regular practice to use parentheses even if you pass one argument, and even if syntax of the language is allowing you to write it like this. Also, I want you to notice the first thing, that it's a function expression, because you see that the function is at the right side of statement. So const multiply goes first, and then the function proceeds. And also, I want you to remember that that kind arrow function doesn't have this, but it's like pretty strong and like hard to understand examples. We will proceed with them on the next lecture. And now just know that we discussed arguments, and the arguments does not exist on the arrow function. So if you want to use arguments, arrow functions is not for you. It won't ever work. But args are really working. So if we pass args here, it will work as expected. It's just about arguments. And the last topic I wanted to cover today is immediate invoke function expression, and it's a bit tricky because probably you wouldn't have to use it because on the newer code you already have const and let, and everything is scoped and the language is built correctly. So you don't really have to go for that statement, but it's really important for you to understand how it works. So you could read legacy code or any bundler or anything else. So immediately invoke function expression is something which is run at the moment it was declared. So let's imagine I have a function here. It doesn't really have to have a name because we will turn that into function expression. So if we wrap it in the parentheses, like this, it's not function declaration anymore because it's on the right side, because parentheses goes first. So if everything goes first before function, it becomes function expression immediately. And after, we are just giving our parentheses to tell the compiler to start executing that function. And if it will console that log something not much important, we are getting that console log even though we didn't provide a name, even though we didn't call it afterwards. It just sees the parentheses here, and it understands that the function should be executed. And also, of course, you can pass an argument here, which will be, for example, a. And here we are already passing an execution, so value and hello. And here we can just say a. And it's just working as expected. As I said, it's not the syntax you would see every day in the real world, but it's something which you will probably um, encountered multiple times during your interviews, during your, I don't know, in tests, maybe some katas, maybe some tricky tasks on interviews. So it's pretty much important to understand how it works, and that we just wrap it inside of it. But again, it's related to scope, and we will talk about that on the next lecture. So it's okay for now to leave that instance a bit uncovered. And also, I want to say that if we really want to save the return of this function, we can save it simply by the result equals to function. And if it, for example, returned us something, this function returns 5. It's immediately executed, and of course, the result of this function, which is 5, will be stored in this variable. So as simple as that, just know that we can um, store the value of execution, so the result of this function here. And I think all of the files are covered. Now I'm going to visit the chat to kind of see if there are any questions. So let me see what the arguments is. Can we use arguments in for loop? Yes, so we can use it in for loop, but we cannot use it in a for of loop. So let me show that. So if we have our function, which is some all arguments, and we have some kind of a code here, which is, so arguments is not an array, as I said. So we cannot say for let a of arguments. It won't work because argument is an object. But we can say let I a in arguments, and then it will work because in is specific for an object and of is specific for an array. But if you want to run that in a loop, it's much better practice. I mean, no one reads loop with arguments, but you can easily write loops with args. So just write spread operators and you can easily go for of loop. Let element of args, and it will work as expected. What else? Will this code snippet? Okay, I will upload them on Discord if that's the preferable way of like communication for you. I did not understand this question, so.
Can I ask you? It was written by me. If when you assign result to immediately invoke function, is it almost like closure?
It's not exactly like closure. I mean, closure is just a way of declaring some variables inside of a function. So it's absolutely different story. Result will be just the result of this function. So it's not closured, if
Oh,
that's
yes,
what you
I
ask.
understand. I understand what you mean. Okay, thanks.
Yes, so it's absolutely the same as if we would name that function. So const, if we would have some function which will
Yes, sir.
return.
Excuse me. Closure means that function returns function. It means that, yes.
Almost. Closure is basically the constant content, how to say, having something outside of the function scope which will work in the current function. So on the next lecture we will cover that in details, because the next lecture is specifically about closure, about hoisting, and about scope in general. So you don't really have to worry about it for now. So again, do you have any questions? Because I cannot
Yes,
see.
yes, I have. If about binding,
Mhm.
function binding, I almost understand what you mean. That you can bind from one object method. It means in context, it means bind two objects and use the other objects properties, as I understand. Is it?
Not exactly. So by binding, we are binding specific function to specific object, not two objects together. So here I took concat function from one object and I put it here in another
It
object.
means the piece of other object. It means method at this moment, and bind using to get the other another object properties. If there is not the same properties, does it work?
If the so basically bind is not exactly binding. By bind, so the first argument is passed to bind, just makes this in the side of that function.
This a means that object with method, what I'm reading right now,
No,
is
no,
this a is the property of hello. You mean
no.
it's
Yes, it
no, it's
was.
not. Yeah,
It was.
it's declared so.
It's declared, but after we binded it, we say that this becomes another object here. That's why we used bind here,
If
because
another object has not the same properties, does will it work?
of course not. It should have an object. So if I say that object, for example, it will be C and this will be D, it will give me just undefined, because that object doesn't have that property.
Okay, thank you.
Any more questions?
Excuse me. The next lecture will be would be about classes.
No, class is absolutely different topic. I expect it to be a bit later, but I haven't really saw the schedule. But class is not related to functions. It's a bit more complex thing, so it will be.
Yes, but classes in JS is almost function.
Yes, I
But
know, and it's syntactical sugar almost, but it's not the function as we define them in these lectures because it's absolutely different use cases.
thank you.
And yes, this lesson will be uploaded on YouTube, as far as I know.
It was good explanation.
Thank you. So, if you don't have any question, we can finish now. Again, the link of the use strict mode of the browser will be sent in the Discord. Also, the link will be in the YouTube, of course, and I will upload the code as well. So that's all. Thank you, everyone. Goodbye.